Good morning, everyone. I want to take this opportunity to just remind you to silence your cell phone because we have a very important speaker in the house. Okay, so my name is Mickey Hebel, and a few weeks ago I was asked, would you like to do today's introduction of Janet Shibley Hyde? And I said, let me think about that for about 1 second. Yes, that would be probably one of the greatest APS honors I could have. You see, I am a native of Wisconsin, so she teaches my people, and I went to Smith College, which is a feminist, activist, women's institution where we learned about pioneering women, and we always pay great respect to them. So, with no further ado, it is a delight to introduce a friend and a role model in the field. She is also the recipient before you of the APS James McKean Cattell Fellow Award. Janet Shibley Hyde is the Helen Thompson Woolley Professor of Psychology and Gender and Women's Studies at the University of Wisconsin-Madison. For more than 4 decades, her contributions have shaped the field of psychology of women and gender, with profound implications for the broader field of psychology. It is no exaggeration to say that advances made in this important field would not have occurred or would have been substantially delayed if not for Hyde's courage, wisdom, and determined efforts. Beginning in the 1970s, Janet shaped the field of psychology of women, offering an undergraduate course on the topic as early as 1973. Hyde published the major Psychology of Women textbook, Half the Human Experience, in 1976. Defining this field, this text has been studied by tens of thousands of students and is in its 9th edition. Janet's scientific contributions have not only defined the field, but also advanced it. Her 2005 article proposing the gender similarities hypothesis synthesized her own results as well as numerous meta-analyses of psychological gender differences. The striking finding was that more than 3/4 of published gender effects were small or negligible, providing massive support for gender similarities. The implications of the gender similarities hypothesis are profound. For example, if parents or teachers believe there are large gender differences in math ability, they may overlook girls with exceptional mathematical talent, and these beliefs are empirically countered by Hyde's hypotheses. Hyde's body of scientific research reveals that contributions of an extraordinary scientist whose groundbreaking work has left an indelible mark on the field. She is a fellow of the Association for Psychological Science. The Association for Women in Psychology has recognized her with the Pioneer in the Psychology of Women Award, and the International Council of Psychologists has recognized her with the Denmark Grunwald Award for outstanding contributions to the psychology of women and gender. I have such enormous pride to introduce her and let you know that she will be presenting today on Men Are From Mars, Women Are From Earth, the science of gender differences and similarities. And I hope you will help me welcome her.
Good morning, everyone. Thanks for being here at this early hour, although if you're from Central Time, as I am, it's not quite that early. But thank you for being here this morning. Okay, you've heard the title of my talk, and I'll just launch right into it. Before I get into the talk itself, though, I have a brief message. I have a paper that should be out online just momentarily with 4 co-authors. That's some of my newest work, and I'm not going to talk about it today because I'm going to talk about the work that I think earned me this award. But the title of this article is The Future of Sex and Gender in Psychology, 5 Challenges to the Gender Binary. It will be in the American Psychologist, and as I said, I've seen the proofs and everything, so it should be out momentarily. And I think you'll find it provocative. It'll be controversial, but I think it makes a contribution. Okay, when we look at mass media portrayals of the topic of psychological gender differences, what do we see? Well, prominent in these portrayals is something I call the differences model. That is, that men and women are very different from each other. Boys and girls are very different from each other. Here we have a cover of Newsweek. Guns and dolls. Scientists explore the differences between girls and boys, and you can see how differently and stereotypically they are dressed. So it's all about the differences between them. Now, one of the things I have to say as a caveat before I go any farther in this is that meta-analysts, and that's what I do, review existing research. So we're sort of at the mercy of the primary researchers. The primary research I'm going to be reviewing today is based on the gender binary. And we're quite critical of the gender binary these days, but this is just my little caveat. This is gender binary-based research. Probably the quintessential example of the differences model is John Gray's book, Men Are From Mars, Women Are From Venus, and that's what I take the title of my talk from, but twist it a bit. In this book, he argues that men and women are so different that it's like they're from different planets, and communication between men and women is almost impossible. It would be as difficult as Martians communicating with Venusians, or whatever the noun would be. Now, this book is from a few years ago, but I learned that Legendary Entertainment has acquired the rights to the book with plans to develop a feature that appeals to Western sensibilities and develop a companion project for the Chinese market. Apparently, the Chinese are wild about John Gray and men being from Mars and women from Venus. So it's having its impact internationally. Unfortunately, it's all wrong, completely wrong. The science doesn't show that he's right at all. Not only do we see the differences model, but we see models of innate biological causes. So not only are men and women different, but it's due to biological factors and therefore immutable, unchangeable. So here we have another Newsweek cover, The New Science of the Brain, Why Men and Women Think Differently. So there's an assumption that men and women think differently, and this article is going to tell us why in terms of EEG measures of brain activity. Another example of this biological model is Luann Brisendine's book, The Female Brain. She also has a companion volume, The Male Brain, because the female brain was so wildly successful. Here are a couple of juicy quotes from that book. What we found is that the female brain is so deeply affected by hormones that their influence can be said to create a woman's reality. Can't you just feel those hormones seeping into your brain and creating your reality? The female brain has tremendous unique aptitudes and nearly psychic ability to read faces and tone of voice for emotions. All of this is hardwired into the brains of women. As I'm fond of saying, you'll never hear a good neuroscientist use the term hardwired, because the brain is anything but hardwired. It is plastic. So anybody who's trying to sell you on the notion of hardwired, you have to be suspicious of that. Another model of innate biological differences, this from Scientific American Mind, where we split the person in two, and we have his brain on the left and her brain on the right. Very different brains. Not only are men and women different, but women aren't quite as good, and that's the deficit model. Probably the best example here is then president of Harvard University, Larry Summers, who claimed in a very controversial speech that women did not have the math ability to succeed in science and engineering. This was back in 2005. His speech annoyed me. But I fight not with my fists, but with data. So I went to NSF and got a grant to test whether Larry Summers was right. I use a statistical technique called meta-analysis for analyzing psychological gender differences. And I assume that many of you are familiar with meta-analysis, but I'm going to start sort of from scratch with the explanation just to make sure everybody's with me. So we can think of meta-analysis as a quantitative literature review. A more formal definition is that it's a method for quantitatively combining the results of numerous studies on a given question. So let's say we can find 100 studies that have data on gender differences in math performance. We're going to combine all of those together to see what all those studies taken together tell us. One of the things I like about meta-analysis is that it tells us not only whether there is a difference, but how big it is. So this is how we move beyond significance testing and saying, oh, there's a significant difference. But yeah, maybe it's significant, but how big is it? Is it small, medium, large, super duper large, maybe? Meta-analysis has really become the gold standard for conclusions in medicine, education, and psychology. And by the way, we can do it with any two-group design. The techniques I'm just using it for the two-group design of males and females. Meta-analysts go through a number of steps in doing their research. First, they locate all prior studies on the question. And now that we have these great databases like PsycInfo and Web of Science, we really can do a great job of getting very close to finding all of these studies. Next, we extract statistics from each study and compute an effect size D for each study. That'll be the size of the gender difference, and I have the formula for D on the next slide. So each study has its own D or effect size, how big the gender difference was in that study. Then we compute a weighted average D, averaging over all those studies. So if we have 100 studies on math performance, we're averaging 100 values of D. Here's the formula for the effect size when we're applying it to questions of gender differences. The statistic is D. That actually should be a lowercase d, but the PowerPoint thing did not want to let me do that. So it's equal to M sub m, that's the mean score for males, minus M sub f, that's the mean score for females. So how far apart are the male and female means? And then we divide it by the pooled within groups standard deviation. We do that because we're comparing across all these different studies. So one study may have measured math performance on a 50-point scale, another one on a 100-point scale, another one maybe was the SAT or something that's on a 500, centered around 500. So it's not 10 points difference between males and females is not the same on those different kinds of scales. So to standardize it, we divide by the pooled within group standard deviation. So this is kind of like a z-score. It's a standardized score. Notice that D can take on either positive or negative values. The way the formula is set up, it'll be a positive value if males score higher, a negative value if females score higher. Jacob Cohen, a very well-known statistician, gave us some guidelines for interpreting effect sizes. How do you know when you've got a small one or a big one? So according to Cohen, a d-value of 0.20 is small, and that would be also true for minus 0.20, right? So 0.20 is small, 0.50 is medium, and 0.80 is large. I've introduced, and it's catching on a little bit, not completely, maybe it'll catch on with some of you today. I've introduced a fourth interpretation, which is that if you get a d-value less than 0.10, it's trivial. It's basically no difference. My reasoning behind that is that 0.10 is less than half of small. So these are really small differences. Keep those numbers in mind as we proceed so that you can interpret the numbers I'll be giving you. To give you another way of seeing what effect sizes look like, I had a computer generate two normal distributions, in this case 0.15 standard deviations apart. So this would be a d-value of 0.15. And if this was math performance, maybe girls have the dashed line and boys have the solid line. What you can see is that for a d-value of 0.15, there's almost complete overlap of the distributions, which is another way of understanding how small a difference like that is. Also, for purposes of comparison, if we look at gender differences in height in humans, that's a d-value of 2.0. So that's a really big difference. Although even then, there's overlap in the distributions. And if I had more time, I would have some men come up and show you that I'm 5 feet 10 inches tall. I'm taller than some men. Even with a big D value like that, we still have overlap in the distributions. Well, certainly there are stereotypes that there are gender differences in abilities. We believe that women and girls are stronger than boys and men in verbal skills, and that boys and men are stronger than girls and women in both mathematical and spatial skills. I'm going to focus on mathematical skills. That's where I've done a lot of work, and I'll eventually get around to telling you some reasons why math skills are so important. Before I do that, though, I have a quiz question for you. In the U.S. today, what percentage of the undergraduate degrees, the bachelor's degrees in mathematics, go to women? What do you think? What percentage? 10, 25. You can get these data from the NSF website. So it's about 50-50 in terms of undergraduate degrees in math. So if women can't do math, I don't see how they're getting half of the undergraduate degrees in math, despite what Larry Summers says. So this is our first clue that things are maybe not quite what the stereotypes say and not quite what Larry Summers had to say. So with this NSF grant, we conducted 3 meta-analyses. I'm going to tell you about one of them for the sake of time. This was of state assessments. This was a paper that was published in Science in 2008. The grad student shown there, Sarah Lindberg, really was crucial in making this meta-analysis happen. And while I'm acknowledging people, in the award ceremony yesterday, I acknowledged my mentors. One of my mentors was Norm Henderson from Oberlin College, and he was negligent enough not to be at the awards ceremony. This is kind of typical for him, but he's here today. So wave to the folks, Norm. I wouldn't be here without him. He got me going in the field. So, for this meta-analysis, we looked at annual assessments by the states of the U.S. of all children's mathematics performance. They also test other areas, but we were just focusing on math. And this testing is mandated by No Child Left Behind legislation, which is controversial among educators, and I don't disagree with what they have to say, but it generates a ton of data. And so I saw an opportunity, and it's well sampled, right? Because every kid in the state, at least those in the public schools, have to be tested. So we thought, there are mountains of data out there, let's get hold of those. So we contacted the departments of education in all 50 states, asking them for data that we needed to compute D. We asked for it by grade level and also by ethnicity, so we could do some ethnicity by gender analyses. We received responses from 10 states. I assumed that the staffers in the other 40 states were so overworked that they didn't have time to respond. But these 10 states that we have are geographically distributed well around the country, and their scores on things like NAEP match national figures, so I think it's quite a good representation of states. And from those 10 states, we have data from 1.7 million children. This is what I love about meta-analysis. We can put together so much data, and it gives us much greater confidence in the outcome. Here's what we got by grade. Look at those D values. They're basically all 0, right? They're all close to 0. And in fact, if you average all D values over all grades, you get a D value of 0.0065. I don't know what could be more no gender difference than that. So no gender differences in math performance in this 2008 analysis of state assessments, very well sampled. So our conclusion from that meta-analysis is that girls have reached parity with boys in math performance at all grade levels. So we have a pattern of gender similarities, not gender differences. The reason I said that girls have reached parity is I had done an earlier meta-analysis back in 1990 that actually showed some gender differences favoring boys in high school for things like complex problem solving. But that seemed to be gone by the time we did this analysis. Now let's look at some other ways of putting these gender differences in math performance into perspective. This is another study, not my study, but it was done with fifth graders in which they were given word problems in 3 different cultures: the US, Taiwan, and Japan. The fuchsia bar shows girls' performance, and that sort of charcoal gray bar shows boys' performance. Now, some people would say, oh, look, boys do better in all cultures. Well, yeah, but that's not the big phenomenon you see in that graph. The big phenomenon is the cross-national differences. That's where the big effects are. And if girls can't do math, why is it that girls in Taiwan do so much better than American boys? Right? So the big effect here is cultures and how cultures treat math and how they teach math and so on. The big effect here is not gender differences. This is another slide, not by me, but by some others, that also puts the gender difference, I think, into perspective. So in this study, they looked at the strongest predictors of mathematics achievement at age 10, for kids at age 10 in the schools. And so the y-axis there shows effect sizes, and the size of the bar shows how good a predictor that predictor is. What you'll see there is the single best predictor of math performance is mother's education. That comes out in lots of studies. Mother's education is a very good predictor, and partly that may be a proxy for social class, but nonetheless a big one. Other good predictors are home learning environment. They set observers into the homes to see how much enrichment there was there. Elementary school quality was big. Family SES was big. What's the shortest bar there, the least predictive of math performance? It's gender, right? So even though people make such a deal out of gender and math performance, the difference isn't there, and there are much better predictors of math performance. Now, I got a lot of publicity from this 2008 paper. It appeared in Science, and people tend to notice those papers. So I felt like I'd really made it when The Onion, which I have to say was founded in Madison, Wisconsin, but is now in New York, the Onion ran a little feature with mock person-on-the-street interviews. So it said, researchers from the National Science Foundation have found that boys and girls now perform equally in standardized math tests. What do you think? Okay, here we have Max Thomas, a cashier. Great, that's all I need. My wife knowing the exact moment I arrive in Boston if my train left New York traveling at 60 miles per hour. And here we have Luke Casey, an industrial loom operator. But linear algebra was the only thing that ever made me feel like a man. Generally, this study was really well received. I got a lot of really nice emails about it, but I did get some negative ones that I called rants. And at first, I just started deleting them from my computer, not taking the time to respond to them. But then I thought, this is data. I shouldn't be deleting this. So I started, right? I mean, it's data. So I started saving the rants. So I'm gonna show you 2 rants. This is to bring you into touch with contemporary society. Here's Mark. In regard to your study, the cynic would point out that you are a female psychologist. Pretty suspicious. Someone with a political motive to provide a self-fulfilling prophecy for the self-esteem challenged. So apparently he thought my self-esteem was being challenged by reports of males doing better at math. By the way, just so you don't worry, my self-esteem is fine. I thought some of you might start worrying. Here's Norman. If women want to major in mathematics, physics, and chemistry in college in order to get a teaching certificate, then fine. But I would urge you to discourage strongly women from pursuing graduate degrees in these subjects and instead leave them to men. So, and this is 2008, it's not very long ago at all. And I had more like this too. So, and some of these people can be high school guidance counselors. You know, I had fathers who wrote me saying, my daughter wants to go into engineering and her high school guidance counselor told her not to do it because she wouldn't be able to do the math, you know. So these things persist, and that's why when I get an opportunity to talk about this material around the country, I take the opportunity. Now, I've been running on for a long time about math. Why should we care about math? Why am I making such a big deal out of it? I'm going to say that there are two basic categories of argument for why math is so important. For the individual person, math proficiency is crucial for access to all kinds of prestigious, high-paying jobs in science, technology, and engineering. Moreover, there is much demand for workers in those sectors. So if you have those skills, you're going to get a job, and it's going to be a high-paying job. So individuals need to have access to this kind of training, and we don't want to discourage girls and tell them they can't do it. On a national level, we can't afford to waste 50% of our talent in the US, namely wasting all of the female talent, in the global economic competition. We're no longer a manufacturing society. The thing that's going to save us in the global economic competition is our scientific and technological innovation. We do that really well. You don't want to lose talent, so you don't want to turn away all the women who have talent. Okay, let's move on to another meta-analysis. This one is on gender differences in depression. The stereotype is that depression is a female problem. And when Time magazine has a cover story on anxiety, depression, and the American adolescents, what do they show? A photo of a depressed-looking girl. Research that we had before we did this meta-analysis, and this one came out just in 2017, so this is quite recent. Prior research had shown that this gender difference appears between 13 and 15 years of age, not present in childhood, really. No difference between boys and girls in childhood in depression. This question of gender differences in depression had never been meta-analyzed, and I'd had it in the back of my mind for 6 or 8 or 10 years that it should be done, and I couldn't figure out why somebody else didn't do it. It was an obvious thing to do. Why had no one ever done it? Well, we did the literature search using PsycInfo and Medline and all those places, and we got 56,000 abstracts. And suddenly I understood why nobody had done this meta-analysis before. There's too much data out there. And let me acknowledge my collaborator on this meta-analysis, Rachel Salk, whose photo you have there. Rachel is doing a postdoc at University of Pittsburgh Department of Psychiatry. She will be on the job market this fall. It would be very smart to hire her. Because this meta-analysis would never, I mean, she's really smart, and this meta-analysis would never have happened without her. So here we are with 56,000 abstracts. So we processed abstracts, and we processed abstracts. I did some, Rachel did a lot. And then, sort of in the middle of this, a methodological innovation occurred to us. We were getting so many well-sampled, nationally representative studies that we could use just that kind of study that's well-sampled, representative of a whole nation. We didn't have to take all these little miscellaneous studies from one person's psychiatry practice or a study of undergraduates at Harvard or something like that. We had these really well-sampled studies, and sampling is part of the issue when you're trying to look at gender differences. So we switched to that method. We got rid of all the other studies that used various kinds of convenience samples and just focused on these well-sampled national studies. And there are an amazing number of them. We then conducted one meta-analysis on diagnostic measures where they had administered diagnoses to everybody in the sample, and another one in which they had used self-report symptom measures of depression like the CESD or the Beck Depression Inventory or something like that. So 2 different meta-analyses here. Rachel made this collage to show you some of the national representative samples. We have, some of them are US, like Midlife and the US, the Midas sample, but you also see the China Health and Retirement Study, the Nigerian Survey of Mental Health, FinRisk, which is in Finland. So lots of, in fact, if anything, the US is behind in doing these epidemiological studies. A bunch of European nations got together and did them some years ago, so there's a lot of good data out there. So for the symptom meta-analysis, self-reports of symptoms, we were able to use 97 articles and their corresponding data sets. Often the data we wanted were not reported in the articles, so we went to the website or we wrote to the people and got the data. So we had 97 articles and corresponding data sets. That represents the testing of 1.9 million people. So again, this is a huge meta-analysis. I don't want to spoil you for the rest of your lives. Most meta-analyses are not this big. I just happened to have stumbled onto some places where a lot of data was available. And this represents testing of people in 90 different nations around the world. For the diagnosis meta-analysis, we located 66 articles with these nice samples and their corresponding data sets. Again, this was data from 1.7 million people, but not the same 1.7 million in the other one. There was a little overlap, but not much. And this also represents testing of people in 90 different nations. Okay, let's look at the diagnosis meta-analysis first. What results did we get? The results here are reported in terms of the OR, or the odds ratio, which is the ratio of females with a diagnosis relative to the number of males with a diagnosis. And the formula is a little more complicated than that, but you can think, are there twice as many females as males with depression in the population? So what did we get? Averaged over all those samples, all those countries, all ages, we got an odds ratio of 1.95. That is very close to the generally believed value of 2.0, but this is the first time it had ever been determined meta-analytically with as huge a sample as we had. Beyond that, there were some surprising findings. Previously, I told you that it was believed that the gender difference emerged between 13 and 15 years of age. In fact, we had an odds ratio of 2.37 even at age 12, and we didn't have any studies with data below age 12, so it could be early, even earlier than that. But already by age 12, more than twice as many girls as boys meet diagnostic criteria for depression. This graph shows you the developmental trends, age on the x-axis and the odds ratio on the y-axis. What you see is that the odds ratio peaks in the 13 to 15-year age group, and it actually gets up to about 3.0, so about 3 times as many girls as boys depressed. Then it falls back, and the 20s and beyond stays at a pretty even level, actually somewhat below 2.0. So adolescence clearly is the hardest time for gender differences in depression. So just to summarize the results we got, the gender difference was already present at age 12, that was earlier than previously believed. The gender difference peaks at ages 13 to 15, and then it declines in the 20s and remains stable afterward. These adult trends were not previously known. They had not been investigated before, and I think they're theoretically important in a way that I'm going to come back to in a moment. For the symptom meta-analysis, we got a d-value of 0.27. That's not huge. I mean, it's small, it's there, but it's not a huge effect size. And we also had similar developmental trends. I won't even show you the graph. It looks very much like the diagnosis one. Now, we did an intersectional analysis with the symptom studies and an intersection of gender and ethnicity. So what we have in this graph is the d-value for gender differences in various U.S. ethnic groups. So the d-value for gender differences among African Americans was 0.13, 0.18 for European Americans, 0.22 for Hispanic Americans. So you can see there's some variation by ethnic groups. We couldn't compute it for Asian Americans because there were not enough studies, well-sampled studies of Asian Americans, nor were there of Native Americans. So this is an area needing some more research. And they are smaller percents of the U.S. population than African Americans and Hispanic Americans are. So when people do a big study, they just maybe don't get enough people in those smaller groups, but we need to oversample for those groups. Let's pause for a moment and think about the clinical implications of these findings. An odds ratio of about 2 actually means that about 1/3 of all depressed adults are men. And when you hear about the gender difference, it sounds like women get depressed and men don't. But if the odds ratio is 2 to 1, right, that'd be 67% women, 33% men. So about a third of depressed adults are men, and we tend to lose sight of that fact. So there are problems with the stereotype that depression is a female problem. It can lead to overdiagnosis of women's depression, which is not a good thing. It could also lead to underdiagnosis of men's depression. So men may have depression but not get it diagnosed because they are men, and then they don't get treated properly. So these are the dangers of stereotypes and thinking, you know, an odds ratio of 2 means that only women get depressed. That's not the case at all. It also may make men reluctant to seek help because they think of depression as a feminine sort of thing, and a lusty man would not have this problem. I also think that there's some important implications for theory from these results. Theories of depression, and specifically theories of gender differences in depression. And there are a bunch of theories in this area. So previous theories of the gender difference focused on the emergence in adolescence, and they were trying to identify factors that would account for the emergence of the gender difference in adolescence. So that pointed to factors like pubertal hormones, which surge around 12 to 13 years of age, maybe stress, increases in stress at the beginning of adolescence, or maybe peer sexual harassment victimization, which also accelerates early in adolescence. So all of those are reasonable. Now, we have a new finding, the finding in adulthood. So the best theory will also account not only for the appearance in early adolescence, but will also account for the narrowing of the gender gap in the 20s. So we need to go back and look at those factors we were positing as causal and say, well, now what's happening in the 20s that would account for the gender difference narrowing? Implications for research methods. How can, I might make some enemies here. How can single-sex designs be justified even when studying depression in adolescence? I cannot begin to tell you the number of all-girl designs that are done on depression in adolescence. And we can debate about this later because maybe there's somebody here who favors designs. I don't see how you can justify that design because a third of the depressed adolescents are boys. Why would you leave them out of the design? Moreover, you contribute to the stereotype that depression is a female problem by just studying girls. But this is a common design, and NIMH funds designs like this, but I really question the wisdom of it. Okay, that's what I had to say about depression. Let's move on to sex. So we have a meta-analysis of gender differences in sexuality. This was conducted with my former grad student, Jenny Peterson. I'm going to go through this pretty fast because of time concerns. We actually had 2 studies in this meta-analysis. I'm going to tell you about just one of them. For this one, we found 840 articles with usable data that represented the testing of about 1.4 million people from 82 different countries. And in this analysis, you'll see that the countries will become important. Now, we looked at a large list of sexual behaviors and a large list of sexual attitudes. So on the next slide, I'm going to show you the list of attitudes and behaviors that we looked at for gender differences. I want you to guess which behavior will show the largest gender difference and which attitude will show the largest gender difference. You're all psychologists. Let's see how well you do. Behaviors on the left, attitudes on the right. Which of the behaviors is going to show the largest gender difference? Don't be shy. What do you think? Where are we going to get the biggest gender difference? Pornography use. Okay. Okay, that's possible. This was kind of harsh to switch from depression to sex all of a sudden. Maybe you aren't quite ready for this. You were still depressed or something. Okay, so we got some good guesses. How about the attitudes? Where do you think you're going to get the biggest gender differences in attitudes? Condom use? Double standard? Yeah? Okay, I'm going to cut right to the chase here and show you the data, and you can see how well you did as intuitive psychologists. This is the one on behaviors. Next slide will be about attitudes. The effect sizes are shown there on the y-axis, and the different behaviors are shown in different colors. And I don't know if you can see that, but I'll interpret it for you. So the largest gender difference is that big blue bar, and that is in porn use. So somebody guessed that one just right. This study is in Psych Bulletin, and I can send it to any of you if you want it. Second largest gender difference was in masturbation behavior. Men do it more than women. Third largest gender difference was in casual sex behavior. So I'm emphasizing here some larger gender, these are larger gender differences than we've seen in any of the previous meta-analyses. So you do find some larger ones in the area of sexuality. But notice that there are also a lot of behaviors that show gender similarities. Petting, frequency of sex, oral sex, anal sex. I mean, those are all small gender differences. Same gender sexuality, too, is a small one. Okay, let's move on to attitudes. The biggest gender difference, that black bar, is in attitudes about casual sex. Men tend to be more approving of it than women, and that's a whole other conversation. If you look to the far right, you will see attitudes about gay marriage. Women are more favorable about gay marriage and gay rights because those are negative D values, so women scored higher on those. So women are more favorable about gay marriage and gay rights. Now, this study was done a couple years ago, so it'd be interesting now that we've legalized gay marriage to start assessing these attitudes again. So we have a few big gender differences in attitudes, but once again, a lot of attitudes where men and women are quite similar. Attitudes about extramarital sex. Nobody likes that. Everybody's opposed to it. They still do it, but they disapprove of it. And men and women detested it about equally. Now, one of the things we did in this meta-analysis is we did some moderator analyses, and in particular, we looked at gender empowerment measures across nations. So there's a measure called the Gender Empowerment Measure. It's put together by the United Nations Development Program. It's on their website. Anybody who wants to use it can use it. It's just free there and openly available. And what they do is collect data from all participating nations. Not every nation participates, all participating nation. And it's a ratio of, they average this together, but a ratio of women to men for things like parliamentary seats, estimated income, percent of senior officials, legislators, professional tech positions. So a higher score, one would mean that women had perfect equality, and the lower the score, the less equality women have relative to men. To give you some examples, US has a gender empowerment score of 0.76. There are a bunch of nations that score better than we do, especially some of the Scandinavian nations. Turkey, in contrast, has a gender empowerment measure just 0.29, so you can see some of the range of values there. Now, the prediction in this moderator analysis is that you're going to get larger behavioral gender differences in nations with more gender inequality. Larger gender differences in sexuality when there's more of a gender difference in power. And this comes from Alice Egley and Wendy Wood's social role theory that ties the development of gender differences to inequality in societies. So, what did we get? We didn't get significant prediction for every measure, but I'll show you a couple that were very interesting. So that gender empowerment measure predicts the size of the gender difference in casual sex behavior across nations. Notice that it's a negative beta, so that means that you get higher gender empowerment goes with a smaller gender difference in casual sex, which is what the theory predicts. Or low gender empowerment means that you get a bigger gender difference in casual sex behavior. So this is exactly what the theory predicts. In another analysis, the gender empowerment measure predicted the size of the gender difference in masturbation across nations. So to the extent that you have inequality between men and women in a nation, men are more likely to masturbate than women are. Okay, well, these meta-analyses and a lot that came before them, I was seeing a very clear pattern. And so in 2005, I published an article in the American Psychologist titled The Gender Similarities Hypothesis. That hypothesis states, and I stated this very carefully, people misquote it and misunderstand it sometimes, but what it says is that men and women are very similar on most, not all, but most psychological variables. What's the evidence for this assertion? Well, in that 2005 paper, I was able to put together 46 meta-analyses, certainly not all by me and other people, 46 meta-analyses, and from those I extracted 124 meta-analytic effect sizes for gender differences. Then I looked at the distribution of the effect sizes. What I found is that 30% of the d-values were in the range between 0 and 0.10, which I've said is trivial. An additional 48% of the effect sizes were in an interval around 0.20, which is a small difference between 0.11 and 0.35. So, in total, 78% of the gender differences were small or even trivially or close to 0. That's the evidence for the gender similarities hypothesis. There were other variables that showed larger differences, and they're the exceptions. But the big picture is here that 78% of gender differences are small or even trivial. I would note that this finding was independently replicated by Zell and colleagues in a 2015 paper in the American Psychologist, and I'm kind of glad they did that independently, and they got almost exactly the same results with 10 more years of data. Moreover, I argue that there are costs to overinflated claims of gender differences. And I'll give you some examples. One is in education. So, single-sex classrooms and schools are being started in various school districts around the United States in the total absence of empirical support. I mean, there's no evidence. I'll actually talk about that in a second. But school districts are desperate. They want to do something. They're worried about achievement gaps. They want to make kids do better. And so there are a couple of gurus who go around the United States saying, I'll institute single-sex classrooms for you, and that'll fix all of your problems. Kids will start performing better. So school districts fall for this. They don't say, do we have a meta-analysis on this that actually shows, which is the question they should ask, do we have a meta-analysis that shows that single-sex classrooms do better? But, so school districts are doing this. It's costly, too. Here we have a book by Michael Gurian, The Boys and Girls Learn Differently, Action Guide for Teachers. He's one of the gurus. He goes around. And here's an assertion, boys and girls learn differently. That's actually not supported by the data, that boys and girls learn differently. But he goes, he and other gurus go around and do workshops for teachers, and teachers memorize these books and believe that boys and girls are really quite different and have to be handled in different ways. They are so different that they cannot be educated in the same classroom. Would we, I ask you, accept that if people asserted that for race? That white kids and black kids are so different that the white children will go to that classroom and the black children will go to that classroom? We would not accept that. Why do we accept that when we say the boys will go there and the girls will go there? It escapes me. We actually did a meta-analysis on this question. Again, I don't fight with this. I found this stuff so outrageous. I don't have time really to show it to you, but I'll just say, basically, if you look at well-controlled studies, there are a lot of studies with poor methods, but basically there are no differences, in this case, between single-sex and co-ed schools in the way boys and girls perform. So no evidence that they provide superior results. Okay, here are some more thoughts about costs to overinflated claims of gender differences. Again, in education, I worry that we put so much emphasis on girls' depression that it leads us to ignore boys' depression and their self-esteem problems. If you look at the histories of the school shooters, a lot of them are depressed and have self-esteem problems. So there are consequences to ignoring boys because we believe that only girls get depressed, only girls have self-esteem problems. Costs to overinflated claims of gender differences in the workplace. How can we claim that women are vastly different from men But they can do the same jobs as men, and they deserve equal pay. Do you see those? I mean, those just don't go together, right? If women are that different from men, how can we say that they deserve the same jobs, much less equal pay? So I think it's a very slippery slope to argue for massive gender differences. So, in conclusion, the statement that men are from Mars, women are from Venus, clearly is false. It doesn't correspond to the data at all. The truth, men are from Earth and women are from Earth. Thank you very much. So we have time for questions and discussions. Who's got something? Are people supposed to go to those microphones, or? Yeah, please go to the microphones that are in the aisle if you have something to ask.
Hi, thank you for a really interesting talk. I'm wondering if you factored in time historically about when studies took place, since gender roles have been moving swiftly as time has gone by?
Often we use either age of publication or age of data collection as a moderator variable. In some analyses, we find age to be a significant predictor, and in others not. In some of the early meta-analysis, for example, I had one on gender differences in verbal ability way back in 1988, and we found that the gender difference in verbal ability had narrowed over time. So in some of those meta-analyses, we do get a trend over time toward declining gender differences, but we don't not in all of them. In some, not all. Yeah.
Hi, good morning. Thank you so much for everything you've done. When you talk about education literature and you did your meta-analysis on standardized tests, which has motivation for all students to do well so that the schools can be successful, have you looked at any data of other measures, such as like class grade, where there isn't the same kind of motivation to do well, and are there differences there? And if yes, what does that mean?
Right. So I haven't done the meta-analysis on course grades, which is another good measure. One has been done, I think it was by Daniel Voyer, V-O-Y-E-R, and what he finds is that girls get better grades than boys at all grade levels in all subjects, including subjects like math and science, where they're stereotyped to be not as skilled. Girls just get better grades in all areas. So that's been done, but not by me.
Hi. Thanks for that. That was very good. I have a question about the push to educate boys and girls separately. I'm not saying I support that, but from what I understand, the push there is not about cognitive ability per se, but the social and behavioral differences, that boys are more active, more independent, more competitive. They're diagnosed with ADD a lot more, that sort of thing, where the girls tend to be more cooperative. And so the idea is that boys are going to thrive when you put a score to everything and make them compete, and the girls are going to thrive when you put them in an environment where they all get to participate in a group project. I just wonder your thoughts on that.
Yes, you're right. Well, the people who give the rhetoric for the single-sex schooling give a lot of different kinds of rhetoric, but you're pinpointing some of what they say. Let me ask you this: if it is true that all boys have ADHD, which is an exaggeration, but let's suppose that all boys have ADHD and no girls do, would you want to create a classroom of all kids with ADHD? See, that's the problem. And actually, there's research done by Carol Martin and Rick Fabes at Arizona State that shows the higher percentage of girls in a classroom, the better everybody does. Okay? And I think it's because for factors like attention, and of course there are girls who have attention problems too, but on the average fewer of them. So what you want is a mixing, and Rick Fabes and Carol Martin have this wonderful program that they started at Arizona State about getting girls and boys to work together, not allowing the natural gender segregation that kids will impose on themselves if you let it happen, but getting them to work together and maximizing rather than emphasizing differences between boys and girls, trying to maximize them getting along with each other. So you were right in identifying some of the rhetoric, but if you follow the logic of that, it still doesn't lead you to single-sex schools. Thank you for that. Yes.
Hi, thank you for that. That was excellent. My name is also Janet.
Good.
Great name.
Yeah.
I am not an academic. I am an organizational practitioner, and I bump up against these gender myths all of the time in the organization development work that I do. There are entire organizations and entire corporations that are doubling down on trainings that talk about how to be gender intelligent and how to understand that men are naturally competitive and women are naturally nurturing, et cetera, et cetera. So I am curious about popular notions of this and
Right.
how this is getting out into the world in a very massive way in the workplace and how we can best combat that.
Yeah, it's so distressing to me because we debunked most of that stuff back in the 1980s in academia, right? And then we get this notion that women are nurturing and caring. And the thing about competitiveness drives me nuts. When I was in third grade, I had this really high-performing third-grade teacher, and she used to make us play round the world for math. I don't know if you ever did that, but she'd show flashcards, and one kid would start at the back, standing behind another kid, and whoever got the answer fastest got to move on. And so your goal was to get around the world, around all kids, so that you had beaten every kid in the class. That was my favorite moment in school ever. And nobody told me I was a girl and I wasn't supposed to be competitive. I just loved the competition. What can I say? I mean, I think that there are a number, you and I should talk, why don't you email me? We'll talk some more. But I think there are a number of ways of combating those kind of stereotypes. They actually represent benevolent sexism, which Susan Fiske has studied a lot. They think they're being kind by saying women are nurturing and caring and not competitive, and we have to take care of them, you know. But none of it corresponds to data. So I think what we have to do, I try to stress, whether it's in education or the workplace, evidence-based practice. And these meta-analyses are the evidence. So let's talk more.
Hi, thank you for your talk and thank you for all your work over the years.
Just a second, I think I'm getting signals. Do we? One more question. Okay, we're running out of time. I'm sorry.
I'm a firm believer that gender is socially created. And my question, and a lot of research that I've been looking at, is that these gender differences are found in adults. But there are also social norms that these people are brought up with, and it's sort of constructed there. And a lot of research among infants and younger children, 3 to 5, are showing that they don't see these gender differences till about age 5, where the kids actually respond and say that they're not supposed to be better at math, the girls will see a scientist, or, you know, those types of things. So I was wondering if you could potentially speak to how we can help construct these social norms and kind of debunk them younger, and when we're raising our kids, almost like a hidden bias that we're seeing a lot with racial differences.
Yeah.
Excuse me.
Yeah, okay. Yeah, good point. Now, of course, what I do is I try to find out whether the differences are there or not, as opposed to what causes the differences. So those are actually two separate questions. But you're exactly right in saying we've got like IAT measures with young kids where they already associate math with boys but not with girls. So how does that get there? Well, it gets there from the larger culture. And so I think what we have to do. Yeah, because I am a developmental psychologist, so I get really interested in this. Where are kids getting those messages really in the preschool years? Are they getting it from TV, like Big Bang Theory? Or I don't know. You know, what are they watching? Or what messages are their parents conveying to them? And clearly, I came from an atypical house because my dad wanted me to major in chemistry, and that's not, you know, something you would typically tell a girl. So maybe I don't understand the insides of families that are like that. But what we need to do is think more systematically about where the messages are coming from that create those very early differences. I don't for a minute believe they're hardwired into the brain. And we know that they're different in some different cultures. You know, in Romania, the majority of engineers are women. So, you know, so it's an American feature. It's about our American culture and some other cultures. So I think that's a great challenge. If you could figure that out, we'd make you famous. Okay, thank you all so much. I'm supposed to stop now. Thank you.